Welcome, chemistry students. Today what we're learning about is something called stoichiometry. It's a big word, and all it really means is converting masses and moles from reactants to other products using a balanced chemical equations, and that's what this says. So stoichiometry is going to use the mole, and we're going to convert between different things on the balanced chemical equation. So before we start stoichiometry, what we need to know is, why do we balance in the first place? Well, let's take a look at this equation. It's not balanced, and what it says is you have N2 plus H2 equals NH3, or ammonia. Now we can represent these with actual molecules, or just representations of molecules. I have N2 plus H2 equals NH3. Now why do we balance? Well, normally when you balance like this. We put a 2 in front of the NH3, so we have 2 nitrogens on both sides. That changes our hydrogens to 6. Our hydrogens are balanced here. Now, if we take a look at this, why do we balance? Well, it's because we want to follow the law of conservation of mass. If you start with these guys, this and this, take a look. I start with 2 ends. I do not finish with 2 ends when I end this, so this is not balanced. So let's take a look at the appropriate way after we balance this. I'm going to show you a new representation of our molecules here. What this means is that we need 3 H2s. 1, 2, this is my third, and I need another NH3. Now we take a look at my reactants here on the left side, and we take a look at my products. And when we count up the amount of atoms, you can see I have 6 hydrogens on my 2 NH3s and 6 hydrogens in my reactants. 2 nitrogens, 2 nitrogens. It's balanced. So for every 1 N2 that I have, it will react with 3 H2s to form 2 NH3. Okay, so we have a 1 to 3 to 2 ratio. So for every 1 N2, it reacts with 3 H2s, and that creates 2 NH3s. Now, so what would happen if we had this scenario? Let's change this. So now we have 2 N2s, we have 6 H2s. How many NH3s should we have? Think about it for a moment. If you said 4, you're correct, because this still has a 1 to 3 to 2 ratio if you reduce it. Let's try another one. If I have 3 N2s, how many H2s will I react if I form 8 NH3s? The answer is 9. Now, where did these numbers come from? 3 to 9 to 8, 2 to 6 to 4. All these are basically multiples of the first one. So they are all still a ratio of 1 to 3 to 2. It has not changed. Try the last one. If we look at the last one, we have 1,000 N2s reacting with an unspecified amount of H2s and making an unspecified amount of NH3s. Well, if you think about it, then you should also know that the answer should be 2,000 and 3,000, because it's just a multiple of 1,000, just like so. So we know that all of these guys follow something called the stoichiometric ratios, which means to say that stoichiometric ratios are a multiple of the balanced chemical equation's coefficients, and you can see that right here. So we know what balanced chemical equations, and we know a term called stoichiometric ratios, but what is stoichiometry in general? Well, it's the calculation of quantities of products and reactants in a chemical reaction. It describes the quantitative relationship between the products and reactants in a chemical reaction. In other words, it's basically those numbers that we just saw, that ratio from the coefficients from the balanced chemical equation. Now, balanced chemical equations are essential for making these types of calculations. And mole relationships in the chemical reactions. The coefficients in equations can represent both molecules or particles, or actually moles. So they can represent particles and moles, and coefficients are quantities, and so are particles and moles. So the coefficients do not represent what we call mass ratios, but they represent quantity ratios. So if we look at our original equation here, we said 1N2 plus 3H2s equals 2NH3s. And anything we had in here fit within that ratio. There was just basically multiples of 1, 3, and 2. Now what happens if we have a question like this? To perform this example, what we need to do is we have to determine how many moles of ammonia gas are produced from 2.8 moles of hydrogen. What we do is we write down our givens. So we write down what we have, which is 2.8 moles of hydrogen. I write that underneath what I have. I then write what I want to find, which is this right here. Now to perform this, what we're going to do is we're going to go from here to here. We have to have our units in moles, which we do, and we're going to use this 3:2 ratio. So let me show you what I mean. We write down the type of moles that we have down here. We then add the type of moles that's specific to that. So what I mean is we're going to write H2 because that's the type of moles we have. So we specify the type of moles that we have. We want to cancel out those type of moles, so we put it down here, H2. We then put the moles that we want to find on top, NH3. So it says for every 3 H2s consumed, I produce 2 NH3s. So I'm just going to take my coefficients and plug them into this equation. So I put my 2 with the NH3, and I put the 3 with the H2. We then just do some simple math. You multiply 2.8 times 2 divided by 3. The answer is 1.87. But take a look at my units. The units that we cancel always go opposite each other. The units you want go on top. So the units I want to cancel go on the bottom. And our new units are going to be moles, which carries over from the first one, of NH3. Now, can anybody guess what the ratio between 2.8 and 1.87 is? So if I divided both of these numbers by 1.87, well, what you would actually find is that the ratio, sorry, I apologize, if you reduce these ratios, it's still a 3:2 ratio when you do the math, okay? The key thing to understand with the molar hop is that it can only be performed with moles. It cannot be performed with mass. Write yourself a little note to remember this. So the question arises, what happens when we have mass? Well, let's look at this question. It says, how many grams of water are produced from the combustion of 10 grams of hydrogen? If we want to do stoichiometry, we have to first of all understand what do we have, what do we want to find. So we write down our givens. We have 10 grams of H2 and we don't know how many grams of H2O we want to get from that. So this is our given and this is what we want, okay? Now, we have information on one chemical, H2. We want to find it on H2O. So therefore, this is stoichiometry. As soon as you have information on one chemical and you want to find a mass or something or the amount of another chemical, that is stoichiometry. And to do stoichiometry, the first step is we need a balanced chemical equation. So we make a balanced chemical equation. We have hydrogen reacting with oxygen making water. So here's our balanced chemical equation. We then write our givens underneath that balanced chemical equation in the appropriate spot. So for hydrogen, I'm going to write it underneath here, 10 grams. And my mass of water is what I want to find. Now I know that this ratio is 2:2, but it only works for moles. It does not work for mass. So therefore, my second step is going to be to convert my mass to moles. So we take our mass, so we're going to divide it by the molar mass of hydrogen. It looks like this. I'll write it out for you. So I have 10 grams. The molar mass of hydrogen is 2.02 grams per mole because remember it's diatomic. Notice how I didn't multiply this 2 in, okay? Just 1, 2. And so therefore, if we divide that, we get an answer. I have 4.95 moles of hydrogen gas. So as you can see, I've written my information below hydrogen right here. Now what we want to do is we want to eventually find our mass for H2O. So we are going to actually have to go ahead and go from H2 to H2O. This is where we do the molar hop. And when we take a look at the coefficients 2:2. That's also 1:1. So for every 2 H2s, I have 2 H2Os. So if I have 4.95 moles here, I should have the same amount here. So this step is called the molar hop. I will show you exactly how to find that now. So we perform the molar hop. So the molar hop is also known as the molar ratio sometimes, but this is the actual step of stoichiometry. So step 3 is stoichiometry. And we're going to use these coefficients. It should be 4.95 because it's a 2 to 2 ratio, but let me show you how you set it up. You have to actually do the step. You can't always just write it down. So this is the actual molar hop step. We write down the type of moles that we have. So we specify the type of moles. And we have H2 moles. We want to find H2O moles, so that goes on the top. And we want to get rid of H2 on the bottom. Now we have to use the coefficients here. The coefficient that goes along with H2O is 2 right here. The coefficient that goes along with H2 is 2 right there, so we just fill them in. 2 over 2. And 4.95 times 2 divided by 2 is just 4.95 moles, just like we said earlier. H2 cancels out. Your new type of moles are H2O. So did we actually change our moles to something else? No, not really. We just changed the type of moles using the coefficients from the balanced chemical equation. So you can see that we have 4.95 moles. The last step is we have to determine the amount of water we have. Now, I mean the amount we have, the amount 4.95 moles, but we want to know the mass of it. So to do that, we need the molar mass of water, which again is 2 hydrogens plus 1 oxygen. If you add that all up correctly, it should be 18.02 grams per mole. That's 1 oxygen weighs 16 grams per mole, and 2 hydrogens weighs 2.02 grams per mole. So it says, take your moles and multiply by the molar mass. So in this case, what we're going to do is just write our numbers in. 4.95 moles. At this point, you can get rid of the H2O. You only specify really when you're doing the molar hop. And we're going to multiply by a fraction, moles on the bottom, grams on the top. This is the same as saying the molar mass. So that goes in the top there. That's 18.02 grams per mole. Multiply 4.95 times the top number divided by the bottom number. If we take a look, our moles will cancel out and we will get 89.2 grams of H2O. So in summary, if we look at this, we started with 10 grams of H2. We finished with 89.2 grams of H2O. Now you might say, well, hey, sir, that's not a 2 to 2 ratio. Well, actually it is, because it's not a mass ratio. What it is a quantity ratio. So when we take our 10 grams and we turn it into the quantity called a mole, our moles, 10 grams is actually equal to 4.95 moles of H2, and 89.2 grams of H2O is actually equal to 4.95 moles as well. So it really is a 1-to-1 or a 2 to 2 ratio. The steps that we did were balanced chemical equation. We've written down our moles, our givens underneath our equation. We then converted our mass to moles. We then performed the molar hop. We then converted our new moles back to mass. That's the end of today's lesson. Hope you enjoyed it and hope you learned a lot. Thank you. Well, it's all